In this video, I want to give you a little bit of an introduction to the law of cosines. This would be a topic that we would have talked about a whole lot had we had maybe another week of school. Unfortunately, we're just going to be able to scratch the surface, but I want you to see the formula. I want you to kind of understand how it works. Hopefully, you'll take another course that will actually prove the law of cosines. I would normally do that in class. If you want to Google it and find out why it works, maybe check on Khan Academy, you can do that. For our purposes right now, I just don't think we have enough class time left for me to include that in this lesson. So anyway, here's the deal. We've learned how to use angle measures to find side lengths and different relationships within right triangles. Up to this point, we've never been able to use trigonometry to find side lengths and angle measures of triangles that aren't right triangles. It turns out trigonometry can actually be extended to dealing with triangles that are not actually right triangles. And there are two rules. There's something called the law of sines and the law of cosines, and they deal with slightly different scenarios, okay? So let me show you the setup and I'll show you how these formulas work. The labeling that I'm going to use, I'm going to label the three vertices of my triangle A, B, and C. And specifically, the labeling is going to rely on matching up each angle with its opposite side. So this is angle A, its opposite side length that I've labeled with lowercase a. This is angle C, I've labeled the opposite side with a lowercase c, okay? And then this is angle B, I've labeled this with a lowercase b for that side length, okay? So you want each angle and its opposite side paired up, okay? Here's what the law of cosines allows you to do. You can take a triangle that's not necessarily a right triangle, although this will work for right triangles, and it turns out that c squared is equal to a squared plus b squared, looks kind of familiar, minus 2ab times the cosine of c, okay? That is the law of cosines formula. It's not super catchy, but if you notice, it starts out looking like the Pythagorean theorem, and then you have a little bit more added on, okay? Now, this can be used in a couple of different settings, and unfortunately, we really don't have the time to be able to go through every single example. But I want to give you an example of how the law of cosines works. The most typical case for working with the law of cosines is a situation in which you have a triangle that's not a right triangle, and you have two sides and the angle measure of the sides that's between them, okay? So that setup would be something like this. Let's say that my A side had a length of 5, okay? And let's say that my B side had a length of 6, okay? So here are two sides. Angle C would be the included angle, okay? So let's say that this angle here is, let's say that's a 35-degree angle, okay? And I want to find this third side of the triangle. It's not necessarily a right triangle. I have no reason to believe that. We certainly don't have a right angle here, okay? But normally you would label your triangle in a way so that the two sides that form the angle are your A and B sides, and then the angle that's between it would be the C angle, okay? And again, you can label this can come up in any position. It could have been these two sides and this angle, it could have been these two sides and this angle. Okay, this is not the only scenario that you can solve with this, but it is the most common. This is actually a pretty easy formula to use. It's just ugly looking, okay? Basically, you just substitute everything in here. So side C squared, which is the one that's opposite the angle that we know, is going to be equal to side A squared, that's going to be 5 squared, plus side B squared, minus 2 times side A times side B times the cosine of angle C, and that's 35 degrees, okay? Make sure your calculator's in degree mode, okay? We'll be working with degrees in all of these problems. And you can just stick all this in your calculator, okay? So 5 squared is 25, 6 squared is 36, 2 times 5 times 6 is 60, and that's being multiplied by the cosine of 35, okay? Now I get an answer of about 110.149. But be careful, that's equal to c squared. So like the Pythagorean theorem, I'm going to take the square root of both parts, and c is going to be approximately, looks like about 10.495, okay? And anyway, that's our missing angle here. Now I didn't draw this drawing to scale, obviously, so that answer doesn't really look like it makes very much sense. But that's the basic idea with the law of cosines. Did I do a cosine there? Yeah, let's see. 25 plus 36 minus 60 times the cosine of, oh, I made a mistake, sorry. I've got plus 60 times the cosine. Yeah, this actually is drawn to scale. That answer doesn't make any sense. That's going to be a pretty small angle, so this side's probably going to be one of the smaller sides. So let's try that again and see if we can actually put the numbers in right. Okay, let's see, 25 plus 36 minus 60 times the cosine of 35. And then I'm going to take the square root. Okay, so we're going to get approximately 11.85 is c squared. The square root of that, this answer makes more sense. C is about 3.44. So do kind of look at the drawing and think about the angle measures and think about a 35-degree angle should be across from the side that's probably pretty small. So it's about 3.44 units for that side length. Okay, so that's how the law of cosines works. Let's take a look at two more examples here. All right, so again, c squared is equal to a squared plus b squared minus 2ab cosine of c. Okay, so kind of typical type of example here. Let's say I give you this side is 4, and this side is 6, and this is a 55-degree angle. Okay, so again, if you have two sides that are forming an angle, this is a situation that the law of cosines will address. All right, so usually your A and B sides are your two sides that are forming your angle. Your C angle is that, okay? So side C would be opposite angle C, and we can kind of label it that way. So once again, you just pop everything in the formula. It's very much plug and chug. So C squared is going to be equal to side A squared, so 4, plus side B squared, which is 6 squared, minus 2 times the A side times the B side times the cosine of angle C. Okay, and again, we can just pop all this in the calculator. Remember, it's going to give me C squared, not C. So that's going to be 16 plus 36 minus, let's see, 48 times the cosine of 55. Okay, so we're going to get C squared is approximately 24.468. Take the square root of both sides. C is going to be approximately 4.95, okay? And that probably makes sense, okay? 4.95, 55-degree angle, kind of a normal angle size, and that's kind of similar to those measures. That probably makes sense. We don't know what the other angle measures are at the moment, but that's what we've got, okay? Now, law of cosines can be used in some other cases. If you notice, you have all three sides, and you have an angle measure, okay? So actually, if I wanted, for example, to find an angle measure, that sort of thing, I could also do that, just to show you that real quick. All right, so say I had all three sides. Say this side is 6, and this side's 7, and this side's 8. And let's say that I wanted to find this angle measure right here, okay? Make that angle measure your angle C, okay? So the side opposite is going to be side C. The two sides making the angle are going to be your A and B sides, okay? So this would be angle B, this would be angle A if I needed it, okay? And we can just pop everything in the formula. C squared, which is 8 squared, is going to be equal to A squared plus B squared minus 2 times A times B times the cosine of angle C, okay? Now this time we're solving for C because we're trying to find that angle measure there. So anyway, we have all this other stuff here. That's going to be 64, that's going to be 36 plus 49 minus, let's see, that's 42 times 2, it's 84 times the cosine of C. Okay, I'm going to subtract 36 and 49 from 64. Okay, and that's going to be negative 21 is equal to negative 84 cosine of C. I'll divide both sides by negative 84. Okay, and what I'm going to get is that the cosine of angle C is equal to 21 over 84 is, well, that's 1/4, okay? And so now I can use an inverse cosine, do an inverse cosine of 1/4, and that should give me angle C, okay? So the inverse cosine here of that answer, and it tells me that angle C is approximately 75.522 degrees. So anytime you have a setup where you have two sides forming an angle, and you have some of the information, you need some of the other information, the law of cosines can work out pretty well, okay? In the next video, I'm going to show you the law of sines.